going through are going to be a review because we talked about R and K selected species last time with our bubble lab, but I'm just going to go over them again just because repetition makes them stick and it'll be easier to understand if there's anything you didn't get the first time around. So, what is a population? So before you can really talk about populations, you need to know what a population is. So, a population is a group of interbreeding individuals of the same species inhabiting the same area, using the same resources, and affected by the same environmental factors. So a population, it has to be same species. So human population, same species. The population of kids at Skyridge, same species. So that makes us a population. Number two, you have to be in the same area. So like if we're talking about a population of people here in Utah, we can't have random people from California or Georgia or Nevada or Hawaii in our population because they're not specifically in the same area. Using the same resources, again, they have to be in the same area because if they're not using the same resources, they can't be considered a population. And again, they have to be in the same area because you have to be impacted by the same environmental factors. All this down. So things that you can look at a population and kind of notice about them or define them by is the size of the population, how big it is, the density, so how many individuals are in a small area or a large area, the distribution, sex ratio, males to females, age structure, which we'll talk about age structure diagrams in just a little bit, birth rate, death rate, growth rate, species interactions, populations interactions, things like that. So all these things go in to make a species what it actually is. So again, these aren't in blue, so I don't want you to write this down yet. So when we look at a species and we look at the way a species grow, we call that its biotic potential. So biotic potential is its growth rate. So you can see like usually when we have a species, this is an exponential growth rate. Because if you have two species and then they have offspring and then those offspring have offspring and those offspring have offspring, it's going to grow really rapidly. So that is going to be its biotic potential. When we look at the biotic potential, you'll notice that, like I said, it's an exponential growth, right? So Devin and I have 2 kids. Our 2 kids might have 2 or 3 kids, or maybe they won't have kids. Who knows? But rude. Excuse me. Okay, but the population is going to grow really quickly. However, there is going to be a point in the population where the ecosystem or the area that we're living in runs out of resources or only has so many resources for a population, and so it's going to stop its growth. And so we call that the carrying capacity. So if you want to think about it like here in our classroom, our population can grow to about 42 students, and then there's no more seats. They would have to start living while sitting on the ground. They probably wouldn't get that good of an education because if you're sitting on the ground, you can't see things, you can't do the labs. And so our carrying capacity would be about 42 students. Our class can continually grow really, really quickly until we hit 42 students, and then it's going to stay stable. That's because we ran out of resources. So resources are what create a carrying capacity. So, for the words, when populations are not limited by resources, growth is very rapid. When graphed, the exponential growth produces a J-shaped curve. So, when we have ample resources or there are no cap to resources, it's going to be a J-shaped curve. Logistic growth describes a population whose growing is initially exponential but slows the population approaches the carrying capacity, which is also known as K. So if we ever talk about something and it says, what's the K of the population? It's saying what's the carrying capacity or what's the max population size that we can feasibly have when graphed. question I like to ask. I'm gonna give you guys a second to think about it, and then we'll pull out our destiny sticks. Do you think the human population has a carrying capacity? If so, have we met it? Have we exceeded it? Can it change? So just some things to think about, and then we'll get some opinions after you guys are done writing. Okay, so like half of you guys are done writing, so I'm just gonna pull random sticks, and this is an opinion question. There is no right or wrong answer. So again, reminding you of the question, has the human population reached its carrying capacity? Does it have a carrying capacity? Do you think carrying capacities can change over time? What's your opinion on that? So our very first question, let's go to the side of the jar, is going to go, oh, they're not here, to, oh, also not here, wow. Destiny sticks suck today. Let's find somebody who hasn't been asked a question yet. Apparently everyone's been asked a question. Jonah. So what do you think? Do you think that the human population has a carrying capacity? Do you think we've reached it? Do you think it can change? What's your opinion?
I think there is a capacity. I don't think we've reached it yet, but I think we're getting close. I think there's stuff that we can limit it from it maxing out, you know?
Mm-hmm.
But I don't know what that is exactly, how to stop it. So.
Cool. So your opinion, there's a carrying capacity. We haven't quite reached it yet, but we're getting close. Okay, let's see if there's any other opinions out there. Let's ask Jay. Where are you sitting? All right, there. What do you think? Do you think we have a carrying capacity?
I do think so. I also don't think we've reached it yet. I think there could be too many people in one area right now.
Mm-hmm.
If we were spread out more, I don't think so. And I do think it could diminish because like our resources are diminishing, which I feel like we're getting a little bit of carrying capacity.
Cool. So you're saying maybe regionally we've reached the carrying capacity, but as like a whole human population, we haven't gotten there quite yet. But with how we're using our resources, we might be taking that carrying capacity and like making it lower. Good opinion. Okay, let's get one more opinion as we go forward. Hank. Where are you at, friend? There you are. Okay. What's your opinion?
I agree with everybody else. I think that there's definitely a carrying capacity, but we haven't reached it yet. And I think it'll be a while because like there's people that are born and die. So
Yeah, so you're saying if our population growth is stable, then we're pretty set. That will be okay with our carrying capacity. Cool. Honestly, I don't know. I have no idea. I definitely think the carrying capacity can change because like we've changed how we make food and like we've learned how to make food more effectively, and so like that can raise the carrying capacity, and like we've been able to like have more medicine, which can also change the carrying capacity. But yeah, there's like so many unknowns that I don't know. I think it's just a really fun thought experiment. So that's why I like to ask the question. So like I said, you don't need to write this down if you feel like you understand it from the last slide, but the carrying capacity is the maximum population size of a species that a particular ecosystem can sustain. So it's determined by environmental resistance or limiting factors. So remind me, we talked about limiting resources, right? We talked about how nitrogen and phosphorus can be limiting resources because they're things that can either make plants grow or stop plants from growing if there's not enough of it. So what do you think a limiting factor could be? So again, we don't know the answer, so just give me your best guess, Portia. So if a limiting factor or a limiting resource is something that can stop plants from growing because there's either too little of it, what do you think a limiting factor could be?
An environment.
Yeah, in an environment. So like, what are some things that could like stop a population from growing because there's not enough of it? Yeah, exactly. Water would definitely be a limiting factor. Another idea of limiting factor could be food, could be shelter, So basically anything that you can run out of as soon as a population gets big enough, that's gonna be a limiting factor, and that's what's gonna play into the carrying capacity or the K. So when we look at limiting factors, there are two different types of limiting factors we can talk about. We can talk about density dependent limiting factors and density independent limiting factors. So a density dependent factor depends on the density. So these are gonna be factors such as shelter, food, resources, all of those things are going to diminish the population because it's affecting them. Other ones can be disease, so if you have like a really big group, there's a bigger chance of spreading diseases around because there's so many people interacting, like you saw that with COVID. In areas where there's high populations, COVID spread really quickly. In areas of low populations, it spread a little bit less. So those are gonna be things, so density dependent factors are factors that depend on the density. So the more individuals you have, the bigger of a problem it's going to be. The second one is a density independent limiting factor. So this doesn't matter how big the population is. So like a drought is going to hurt populations no matter how big they are. A fire is going to hurt populations no matter how big they are. Temperature, if it gets really, really hot, it doesn't matter how big your population is, if you can't withstand the heat, you're all gonna die. So these are things that can affect population size, but it doesn't matter how big the population is. Big population, small population, they are affected equally the same. So as soon as you're done writing this down, I want you to turn to a partner at your table, or if there's only 3 of you, go ahead and, hey Charlotte, let's have you move over next to Annika so you're not on a table all by yourself. Find someone to talk to. One person describe density dependent factors and somebody describe density independent factors.
Run size, more people, more problems, independent. Events, fires.
Density dependent are like something based on the factors based on how big the population is. So if there's more people in the population, it's like a bigger problem.
Make sure you're discussing, so I'm gonna ask somebody with density stick style what their answer was. Are you a density dependent or density independent? So make sure you have an answer. So somebody's gonna describe density independent, someone's gonna describe density dependent. So, Braga, kind of move over here next to Jay, so you guys can talk to each other, you guys can talk to each other. Sure, maybe your turn. Okay, sir. Alright, so let's see who the density sticks are picking today. So the first person gets to choose if you want to describe density independent or density dependent. And I will keep the slides up just as a reference point. Jackson, where are you sitting, my friend?
Density, like, it depends on the size. So if there's like a bigger population, it'll probably have more of an impact. But yeah, like disease and competition.
Perfect. So density dependent factors are factors that will affect the population, but it will affect the population more if there is a bigger population. So like you said, disease, limiting factors, things like that. Okay, so our next person is going to describe a density independent factor. She's not here. Let's do Lucy. So what's a density independent factor then?
Density independent are things like fires and floods where no matter how big a population is, it's still going to be.
Perfect. So density independent factors are factors that no matter how big the population is, it's going to affect the population because it's something that is going to be detrimental, like floods, fires, things like that. Awesome answers. So So you can see that when we look at populations, at the very bottom we're gonna have renewable resources, and these are gonna be things that are gonna be really good for the population because you need renewable resources in order to survive. But our non-renewable resources are gonna be the things that are gonna be causing some limiting factors or that can play into the carrying capacity. Because as we use them up, like was said when we were talking about our carrying capacity, Jay said that she felt like the carrying capacity could be limited because we are going through our non-renewable resources and we're limiting the things that we have. It can make a population go down. As the non-renewable resources go down, the population is gonna also go down. So when we talk about a population growing, remember we start with an exponential growth because we have a J-shaped curve, there's plenty of resources. The population is gonna grow really, 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 really quickly, and then eventually it's gonna go over the carrying capacity because like the population doesn't know when to stop. It just keeps on going. But as soon as you go over the carrying capacity, you're gonna go through a period that's called die-off because there are too many individuals in the population, and because of that, there's not enough resources to sustain them, and they're gonna start dying off. Eventually, they're going to overshoot the die-off period. They're gonna go too low, and then there's gonna be more resources than individuals. So they're gonna grow again and go too far, and then they're gonna go down, and eventually it's going to oscillate and go into like a stable population environment. So whenever we see a population growing in an environment, so like a brand new population in an environment that has plenty of resources, we are always going to see an overshoot period. And then overshoot periods are always followed by a die-off period because there are too many individuals in a population and the ecosystem cannot cover it. They can't provide for it. There's not enough resources to make them healthy and happy. And then after the die-off period, you're gonna kind of go back and forth. And so the big idea is that populations cannot survive beyond the carrying capacity of their habitat. That is not possible. You cannot live in an area if there are not enough resources for you to survive. Alright, so you guys asked for brain breaks because notes can get tedious. So what I have for you guys, this is my favorite thing to do in the world. These are chalk markers. So I want you guys to draw on the desks. Which is like really fun because you guys are told your whole entire life, don't draw on the desks. So you're gonna draw on the desks, and what I want you to do is I want you to draw these curves. And I want you to label like where exponential growth is happening, where the carrying capacity is, what is an overshoot, why does it happen. So I want you to draw it, and then rather than doing the person next to you, I want you to do the person across the table from you, and I want you to like kind of explain what you drew. And if you have to draw like little hearts and stars and like other things on your desk, that's totally okay as long as it's appropriate. If it's not appropriate, I will take your marker and I will make you feel shamed for drawing inappropriate stuff on my desks. Yeah? Okay. Because we used to do a different lab where you would have to use balloons to work with the population. It was like I just had to share your markers. I ran out. But I didn't like it anymore. Now there's just for funsies. I don't have any more. Okay, then you gotta share somebody else. I'll buy some more chalk markers for this class. Yeah, so if you run out of ink, have your neighbor share their chalk marker with you. Oops. Oh my gosh. themselves with their chalk marker? When they were shaking it, like. Okay, so as soon as you're done drawing it, go ahead and talk to the person across the table from you and explain what you're seeing, how does it work, why do you see the slopes and the falling as you do. Alright, go through the chalk marker. I got some more from Mrs. Anderson's class. Who needs one? I'd actually draw on the tables. You don't see the chalk marker? Alright, do you guys need more time to explain your graphs to the people at your table? Okay, so now that you've drawn on the table and had fun with this, I'm going to ask you to cap your chalk marker. You're going to keep it because there's going to be more drawing to be had on the table, so make sure there's some kind of space for you guys. And you can change colors if you need to so you can like see the different stuff we're drawing. But go ahead and cap them and put them in the middle. Let's do a vote. So fist to 5. 5 means I understand population growth, I understand carrying capacity, I understand overshoot and die off, I understand limiting factors and like density dependent, density independent, I understand all that. 1 means D-Heart, maybe you should be a car salesman because that just doesn't make any sense to me. So, show me fist to 5, where are we at? How are we feeling about this material? Alright, cool. So, let's continue. So this is just a review picture, like we said. Populations are going to grow, they're going to overshoot, and then they're going to come down. The big idea of this picture that I want you guys just to kind of internalize, you don't need to write it down, but just something to realize that if the die-off period is gradual, like if some of the population dies off, but it's not that big of a deal, then it can come back. But remember we talked about R and K selected species, and we said that K-selected species, if they have a big population die-off, it's going to be really hard for them to recover because they only have few offspring. So if a population dies really, really quickly because they overshot too far, it could completely kill the population. So this dynamic, like ideally, it should oscillate and find a really good carrying capacity. But depending on the type of species reproduction strategy, R or K, you might have a population completely die off if they go way too far past their carrying capacity. So, continuing on, like I said, this stuff right here should be a review for you. So, if you don't want to write this down, you don't have to. Again, this is the third unit that we talked about generalists and specialists. So let's do this. Specialists are animals that live in a very specific area. They need specific things, and their tolerance is real, real small. Generalists, on the other hand, are animals that can live basically anywhere. They can eat anything. They can withstand lots of different temperatures, and their range of tolerance is really, really big. So, are we good with generalists and specialists? I feel like we're beating a dead horse now. Talked about it so many times. So going on, I know that's a really stupid saying. I don't know why you would beat a dead horse. Maybe that's why it's a saying, because like you wouldn't, because it's dumb. Again, range of tolerance. We've talked about range of tolerance. I talked about it with my spiciness levels. Specialist species are going to have a very small range of tolerance, where generalist species are going to have a very, very big range of tolerance. Work with me here. There. Which brings us to R and K selected species. So this is what our bubble lab was about last time, about the amount of parental care that's given, the size of the species, how many offspring they usually have. So we talked about the majority of this, but here's some more information about R and K selected species. So remind me, I'm gonna ask this question, popsicle stick style. When I say R selected species, what animal did I tell you to think about to help you remember? R stands for what, Will Smith? For rabbit. So we were talking about it last time. We said that, remember, R is rabbit because they reproduce really quickly, they have a lot of offspring, not a ton of parental care. So what does RK stand for? Sorry, I put dots next to your guys' names when I pull your stick so that I don't ask the same people a million times. Charlotte, what did we say K stood for? Kangaroo, right? Because kangaroos are big animals. They take care of their offspring. They have a pouch for them. So just reinforcing that idea for you guys. So R selected species, they are usually really small species. So like rodents and bugs and things like that. They have a very short lifespan. They do not live for very long. They are able to reproduce really early in life. So like, for example, guinea pigs. Growing up, I had guinea pigs. And we had 2 guinea pigs that we thought were girls, but one of them got pregnant, so we learned that one of them was not a girl. And as soon as the offspring were in the cage, you had to take the dad out of the cage because in like a couple of days, the offspring were fertile and they could reproduce. And so you had to like separate the guinea pigs to make sure they didn't start getting pregnant and having more guinea pigs. So they can reproduce really, really early, which makes their population grow really quickly. They have a lot of offspring. They're usually small and there's not a bunch of parental care. The population can grow really quickly. The thing that regulates the population are density independent factors. So the things that really affect this population, since they die so quickly, they don't usually like stay above the carrying capacity because like with our graphs, we saw that they died really early in life. So density independent factors are gonna be the things that are stopping their population. And then there's very low competition. On the other hand, for K-selected species, exactly the opposite. They're large, they have long lifespan, they can only reproduce late in life. They have few large offspring, there's lots of parental care. Their population growth rate is slow. Density dependent factors are what are gonna stop them. So they're actually not gonna hit the density dependent factors very often because their population is not gonna grow very quickly. And then their competition is really high. They have to fight for their food. So, R and K selected species. Do I need to go over them anymore? I feel like we kind of understood them with the bubbles last time. Can I get a thumbs up? We're ready to move on. Dope. So again, we talked about this last time, that invasive species are more likely to be generous or R selected species, and endangered species are more likely to be K. So, invasive species, again, we've talked about this a couple different times, but I'll go over it one more time just to make sure we're comfortable with the idea. Invasive species are species that get introduced into a population and they're not meant to be there. They are not native, they are not natural, and so because of that, they take over an area and they reproduce quickly and they will outcompete other animals for their food. The animals that they are outcompeting are more likely to be specialist or K-selected species because they do not reproduce very quickly, they need to live in specific situations and specific environments. And so they cannot handle being shoved out of their environment. Okay, let's do another little break since you guys are looking like your eyes are being glazed over. Grab a different color marker. On your table, decide if you're going to do R selected species or K selected species. And I want you to write down everything you can remember about that type of species. Okay, this one is. Nope, okay, you can do it. You're a R or B species, and you're just gonna list everything you know. So like R species, they're small, early, dioxically, generalist. And if you can do it not looking at your notes, you get extra points, which doesn't make a difference because I'm not giving you any points. But hey, if it motivates you. Driving through, see if you can do it. It's a very beautiful bunny though. I like it. It's great.
I try my best.
Or you succeed.
It is going to make it.
If you have a dying marker, I will take it from you and give you a new one.
Okay, this one just
So close. Here's a deep one.
Last year was. Pretty good.
Alright, so let's bring it back together now that we've kind of had time to draw on the table and have fun with that. Again, this is something we talked about last time. So these are the 3 survivorship curves. We said that survivorship curve number 1 is what type of selection, R or K? And this question is going to someone who hasn't been asked a question yet. They're all here. Trevor! So, survivorship curve number 1, do we say that this was an R or K selected species? K selected, right? They live for a long time, they have a long lifespan, very few offspring, lots of parental care. Alright, what did we say survivorship curve number 3 was? K. So we said that this one was K, so what does that make number 3? You got it. R selected species, lots of offspring, but they die very quickly, they're really small. And then last time we did talk about how there are some that don't fit into either category. And so there are number 2. Maybe they're really large, but they have lots of offspring. Maybe they're really small, but they have a lot of parental care. So they are going to be right in the middle. So we drew this in our notebooks last time as well. So if you want to go back and add anything to it, you're welcome to. If you feel like you understand it, you don't have to write anything down. Okay, so if you feel good about this, I'm actually going to tell you guys to go down to the drinking fountain at the end of the hallway, go get some cool air, go get a drink, move your body, take a break from sitting down, and then we're going to come back and start playing with Legos. So, go get a drink. If you don't want to get a drink, you can just like stand up and move around. Do something to get your blood flowing so that you're not falling asleep. Okay.
I draw that, like she can do any better.
Yes.
I didn't get like the homework sheets last time.
Oh, okay. Yes, they are over. See that like paper holder? The fourth one down that's just yellow and there's like smaller sheets.
Okay.
Yep, grab all of those. So just grab like a unit cover sheet, grab the homework, grab the guided notes if you want them.
Hey, so I
Right.
have my Sterling Scholarship interview during Sky Time
Yes.
at 10:30.
Okay.
Is it okay if I leave just like, a couple minutes early? 'Cause
Absolutely.
it's the vocal performance one and it's still early and I haven't done a lot of
Yes,
anything,
absolutely.
so-
Whatever you need.
Okay, thank
I
you.
also have a question for you.
Yes.
Since you're in the science department, do you know who's the science person for the Sterling Scholar?
Julie Johnson. Yes.
So just these
Yeah, those three. And you guys all got red or pink. It's wild. I'll come around and spray your guys' staples too. At the very end before we leave.
They're just vandalizing me.
For real though.
You have some vandals in your class.
It's okay.
They put stink lines over Bugs Bunny.
Rude.
They're not on him. They're on his carrot.
Maybe his carrot's stinky, but he's not.
He is.
going to the cemetery next time. So remember, on Halloween, we are going to the Lehigh City Cemetery, so bring warm clothes, bring a jacket. If your costume is a costume from Mean Girls, make sure you have something to put over yourself so you're not frigid, or I will laugh at you, because I'll be like, I told you a bajillion times to bring warm crap. Come on in, friends.
I'm just ready to watch.
Okay, cool. So, if you take an AP Human Geography, this next part is going to be cakewalk for you. So, human populations change just like any other populations. We've kind of talked a little bit about human population, about like the carrying capacity of the world and whatnot. So, the things that change human population are going to be birth rates, death rates, immigration, and emigration. So just to remind you, M with an I is when individuals are moving into a population. M with an E is when people are exiting. So I is for in, E is for exit. So just like any other population, human populations are limited by resources, the Earth's carrying capacity, and both density-dependent and independent factors. So everything we've talked about, our population is definitely impacted by as well. So, like we talked about how populations grow, human population is no different. Goodness. Come on. You can see that human population is definitely a J-shaped curve. Has definitely gotten more exponential as the years have gone by. What do you think that this dip is right here? No, it's not COVID. This is 2000, friend. COVID is over here. But, okay, we're close with COVID, though. The plague. This is the Black Plague. So there are very few places in human population history where we've actually gone down. And one is the Black Plague, and then there's one that we had a pandemic in Europe. So those two things are the only reason. But you can see right here, after like industrialization and the Green Revolution and like medicine, our population has gone through the roof. So, talking about medicine, there's something we need to talk about, and this seems like a really weird thing, because like when I explain it to people, I'm like, yeah, we're learning about LD50. They're like, what's LD50? I'm like, oh, it's just the amount of stuff you need to kill 50% of the population, and they're like, why are you teaching kids this? So LD50, like I said, is the dose of a chemical that is lethal to 50% of the population in a particular species. The reason we talk about this is because this is what creates the doses for Tylenol, ibuprofen. So in order to have a dose that you can take, the LD of it has to be like 0.000000001. And so we need to know what the LD50 is to know like what the tolerance of a specific chemical is, so that we know how to keep our populations alive. So this is what manufacturers for literally anything you eat have to be aware of. They have to be aware of the LD50. So if I'm showing you a graph of LD50, and you're welcome to draw this graph on your table if you want to with your marker, just to have funsies, or you can draw it in your notebook, whatever makes sense to you. If we're looking at this, so say that this is 0, this is 25, and this is 50, and the question on the test was, what concentration is the LD50? What would the answer be?
50.
So if this is 0, 25, and 50.
25.
Yep, 25. So where 50% have died is going to be the LD50. Let's see if there's a better graph. There we go. Okay, let's practice this one. With your table mates, at what dose do we see the LD50 in this population? Don't say it out loud. Keep it in your brain. So talk with your table mates, decide at what dosage is the LD50 for this graph. Okay, has everybody decided what dose the LD50 is for this graph? I'm about to pull a popsicle stick. Actually, I have a popsicle stick in my hand, so make sure you're ready to answer. Okay, it's Rachel. At what point is the LD50 on this graph? And you can give me like abouts.
Like, right around 60-ish, 50-ish.
So we have, this is the percent, so absolutely, so you'd be at 50. So the percent on this side is the percent of the population that has died. So 0% of the population has died, 20 died. So that 50% of the population dying, like what number and then dose on the bottom do we hit?
100.
Yep, you got it.
Oh.
Yep. So that's how you read the graph. Percent population on the side. So just like we did our graph last time. So the percent of the population that's affected. 0% of the population up to 10 is fine, but as soon as you get to 100, 50% of the population dies. So that's LD50, kind of morbid. The only math you need to know for this unit is called the rule of 70. So the rule of 70 states that it's the amount of time needed for a population to double. So doubling time equals 70 divided by the annual growth rate. So make sure to write that down. Huh? So the rule of 70 is calculating the doubling time for a population. So doubling time equals 70 divided by the annual growth rate. So to practice, it says the current world population is 7,600, lots of zeros. So how long will it take to double if the annual growth rate is 1.1? So when you're doing questions like this, don't get confused or don't get distracted by these big numbers. Because do we care about the current population size? No, we do not. What are the two things we care about? The growth rate and 70, right? So what's 70 divided by 1.1?
63.6.
Perfect. 63 years. So we'd expect 63 years for it to double. So does that make sense how to do the rule of 70 growth rate of the population? Cool. Skip all those. Those are meant for practice. This is where we get to play with Legos. So we have like 10 minutes left. We're just going to kind of get started in this concept, and then we'll talk more about this next time. But I want you guys to pick one of these pyramids and make them with Legos. So make sure you don't have the same one as anybody else on your table. So I don't think there's only one table of 5. So everybody should create their own pyramid with Legos.
Stage 3.
I do.
actual pyramid, is what she's saying.
Except this is how.
Yeah, like do your best. You're not gonna get. Oh yeah. Hey.
Actually, this is only the first one.
Yeah, that's actually a really good example of the first one.
Thanks.
Boom.
Beautiful. Kinda like Pac-Man goes to me. You're killing me, Smalls. There we go. Okay, so as you're building your pyramid, I want you to like remember in your brain, is your pyramid the pre-industrial pyramid or stage 1? Is your pyramid industrializing or stage 2? Is your pyramid industrial or stage 3? Or is your pyramid post-industrial or stage 4? So does everybody know which pyramid they've built? Can I get a thumbs up if you know what your pyramid you built? Either the stage or the name of it. Okay. So this is the last thing we're gonna write down. If the projector will stop being a dirty word.
Whoa.
That's what I mean. So stage 1 is where you have a population that has very, very slow growth. And the reason you have slow population growth is because you have high death rates and high birth rates. And the reason you have high death rates and high birth rates is because you have disease and you have poor sanitation. So those two things are keeping the population from growing. This is the very last thing you're writing, don't worry. All four. I believe in you. Stage 2 is rapid population growth. So the reason that this population is starting to grow quicker is because we have better sanitation and we have access to healthcare. So as soon as you fix the sanitation and the disease problem, populations tend to grow really, really quickly. Go figure. Alright, so as soon as we have good sanitation and access to healthcare, we are going to start slowing down our population growth. And that's because we have more education, we have more economic opportunity, and we have more cultural changes. So all of these things have to do with women. Sorry, dudes. But it's because women are getting more educated, which means that women are in the workforce, which means that women are not going to be having as many kids because they are working and somebody else has to take care of them. And so, for example, my grandparents, both of them, one of them had 9 siblings, the other one had 12 siblings. And that's because both of my grandparents lived on farms. And so having a crap ton of kids was awesome because free labor, right? So all of these kids, took care of everybody. My grandma, she was in charge of actually cooking dinners. So as she had her own family, it got hard for her to like cook in small portions because she was used to cooking for a very large family. On my grandpa's side, my grandpa was one of the youngest, and so he was actually raised by one of his siblings. His mom was busy working on the farm, and so one of his siblings was in charge of the littles, and so that's how he was raised. So So having big families was great. But now, having big families is really expensive. So I am the youngest of 4 kids. So my parents, my dad is the youngest of 7, my mom's the youngest of 4. So their group of kids went down, like the number of kids they had went down, went to 4. And then for like my husband and I, maybe we'll stop at 2. Maybe we'll have 3, but 3 is like the max. And so like the number of children that individuals are having is going down because culture is changing, because it's expensive. So for example, I just like did the math, which makes me want to vomit just a little bit. But I pay almost $2,000 a month in childcare. So that's just for 2 kids. And so like having more kids is not going to be like, this sounds really bad, but like it's not going to be an economic help for me. They're not going to be working in the field and like helping my income. I'm actually paying for them. And so as economic opportunity, as women are more in the workforce, as we have more education for women, and we have cultural changes, our population is going to start to slow down. And then we have stage 4, which is the population does not grow at all. So we have rising death rates, we have low birth rates, and the population has a higher number of elderly and fewer children, which is what we're heading to right now. Because a lot of people of my generation are like, you know what, I don't want to have kids, which is totally fine, and they don't want to have kids. However, with Social Security, the working force pays for the retirement of the older force, which means that by the time y'all are retiring, there might not be enough money to actually provide for your retirement. So stage 4 post-industrial is where we have fewer younger children and a lot of older people. So we're gonna stop there because we are gonna talk more about this growth model as we look at the Lehigh City Cemetery, which means you're gonna bring what next time? Jackets, please bring jackets. I only have 2 blankets. So if someone forgets and they need a blanket, I only have 2 people I can rescue. So make sure to bring something to wear that is warm. We're only gonna be there for like half an hour, then we're gonna come back and like share our data. I'm gonna assign you guys different parts of the cemetery to get data from, and then we're gonna come back and start crunching the numbers and talking about how the population of Lehigh has changed over time with years and things like that. Can I get a thumbs up if that makes sense? Dope. Okay, so you guys have 2 minutes left in class. Skytime's gonna start after that. I'm gonna come around with spray bottles and spray your guys' tables so you can erase the beautiful drawings you have drawn. But thank you so much for being strippers. We're not gonna have any more big note days like this for the rest of the unit. So, thanks for being awesome.